Let's continue our work with adding fractions. We know when we add or subtract that we must have a least common denominator. But this time, our denominators and our numerators have variables in them. That can make things tricky. Let's try number 1. I'm adding fractions, so I need a common denominator. Let's start with the numbers, 6 and 7. Does 6 divide evenly into 7? No. Then I'll multiply 6 times 7 to get a common denominator of 42. Now both denominators have a's, so I'll need an a as well. Now let's get the numerator. What do you multiply times 7a to get 42a? Is 6. We'll multiply both the top and the bottom by 6. 6 times 15 is 90. For this one, what do you multiply times 6a to get 42a? Is 7. Then we'll multiply the top by 7. 7 times 8 is 56. Let's keep that common denominator. Add up the numerators. 90 plus 56 is 146. That's a great answer. Let's see if it reduces. 146 and 42 are both divisible by 2. 146 divided by 2 is 73. 42 divided by 2 is 21, so that's 21a. Perfect. Let's try number 2. I need a common denominator. Well, when I get a common denominator, I first check to see if one of them divides into the other. Well, neither d nor 5 can divide into the other. So I can get a common denominator by multiplying them together. 5 times d makes a good common denominator. Now for the numerators. What do you multiply times d to get 5d? I multiply by 5. Let's multiply the top by 5. 5 times 4c is 20c. What do you multiply times 5 to get 5d? I'm multiplying by d. Let's multiply the top by d. But if I multiply d times 8d, I'll get 8d squared. D squared because I'm multiplying these two d's together. Keep the common denominator. And I'd like to add the numerators. But this numerator has a c and this numerator has a d. Those are not like terms. And since they're not like terms, I can't really add them together. All I can do is show that I would like to add them together as 20c plus 8d squared all over 5d. That's a complicated looking answer, but it's perfect. Let's try 2 more. Here we need a common denominator. I'm going to check to see if the small one divides evenly into the big one. Well, x fits very nicely into x squared. Let's just use 3x squared as my common denominator. Let's get the numerators. What do you multiply times 3x squared to get itself? Well, you're multiplying by 1. 1 times 14 goes right here. What do you multiply times x to get 3x squared? Well, I'm going to multiply x times another 3x so that 3x times x is 3x squared. But if I multiply the bottom by 3x, I must multiply the top by 3x. 3x times 6 is 18x. Keep that common denominator. When I add the numerators, this does not have an x, this does have an x. Those are not like terms. If they're not like terms, then I can't really add them. All I can show is that I would like to add them and leave it like that. Here's number 4. I notice in number 4 that this is not a fraction. Let's make it look like a fraction. We'll put it over 1. Now I need a common denominator. Check to see if the small denominator divides evenly into the big denominator. Well, 1 divides into anything, so x squared can make a good common denominator. For the numerators, what do you multiply times x squared to get itself? Is 1. Multiply the top by 1. What do you multiply times 1 to get x squared? Well, we'll have to multiply by x squared. X squared times 1 would give me x squared. But if I multiply the bottom by x squared, I must multiply the top by x squared. Now, x squared times 5x is 5. There's 2 x's there, another x there. That's 5x to the third. Keep that common denominator. I'd like to add the numerators, but they're clearly not like terms, so I'm not allowed to add them. I'll have to leave my answer just like that. All right, these are challenging. I know you can do it. Go work some homework problems. I'll see you back here later on.